In this video, I'm going to cover multi-agent systems, how they work, and the benefits of using multi-agent systems when you compare them with single-agent systems. Okay, so we're going to start right at the bottom with simple chat models. So these are just models where you have an input, you pass into the LLM, and then you produce the output, basically like ChatGPT. There's very limited memory, maybe just the chat memory is included in the system prompt, but there's no long-term memory or long-term planning typically. Obviously that's changing every day with reasoning models, but typically there's no long-term planning or memory. Okay, now let's move on to agents. Agents are a bit more interesting. So we have the input is fed into the LLM, then the LLM may actually choose to use a tool call or update its memory, and then the LLM can actually make multiple tool calls, and only then, after doing multiple tool calls, produce the answer. So this is basically a loop, and the LLM repeats this loop until it's accomplished the task that you gave it to do. So let's use an example here. Let's say you want to research a prospect and then book a meeting with them. So you have your input, which is basically telling the LLM to do this. Then the LLM is going to first analyze the input and break it down into tasks, and maybe actually use something called a scratchpad, where it writes down the things he has to do in basically like a checklist, and he's going to add that into its memory. Okay, so that's the first loop. So it goes into memory, updates the memory, and then goes back to the LLM. Now the LLM can actually read through the memory and see, okay, first task is searching about the prospect. So once he sees this, he's going to basically do the first tool call, and this tool call is going to use the search functionality, which is typically an API. And then once he does the search functionality, the results of that search function are going to be fed back into the LLM, and then we're going to go to the next step. So now the LLM can see, okay, I know the prospect, I've researched the prospect. So now the next thing in my checklist is to actually book the meeting. So to book the meeting, the LLM is going to do another tool call. And this time the tool call is going to go to the calendar tool. And this calendar tool is going to book the meeting. And the result is going to be returned to the LLM. The LLM can now analyze this result and say, okay, the meeting was booked. So my task has been completed. So I can exit out of this loop and maybe output something to the user or just completely finish the task. Okay, so this looks great. But so what is the problem with this? Okay, the problem is when you start adding too many tools. Because every time you add a tool, you're basically adding more context and more information to the system prompt of the LLM. And as you may know, the LLM has limited context length. This means the LLM can only understand so much information. And if you take up all of its context length, all of its like memory or bandwidth or reasoning ability, however you want to think about it, if you take all of that up with tools, then the LLM is not going to have anything left to reason and actually be useful. Let's say if you have 50 tools with one LLM, there's a very low likelihood that the LLM is going to pick the right tool every single time. It's just very unlikely, and this is going to make your system very unpredictable, very unstable, and basically useless in that case. It's going to be very unreliable. So the solution is to break it down into multiple agents. So you might have one agent that has access to 3 tools, another agent with access to 2 tools, and then you break it down, you split those 50 tools across multiple agents. This way each agent is highly specialized, and this means that they're more reliable, more robust, and less likely to make mistakes. So let's take a look at how a multi-agent system actually works under the hood. So one thing I want to know is that when you use these frameworks such as LangChain or maybe even N8N if you use low code, is that this is all done under the hood for you, but I still think it's good to have an understanding of how this actually works so you can be ahead of your competition. Okay, so first we still have the usual agent as before, but this time we actually added this tool here called switch agent. So at some point in the conversation, this agent is going to detect, okay, this is no longer my area of expertise. I want to transfer this conversation to the next agent. And at that point, this is going to call this tool, the switch agent tool, and this switch agent tool is going to do some logic, whatever logic that is in your use case, to switch the agent to the next agent in the conversation. So this is basically how a multi-agent system works in the very, very simple terms. In this case, they both have their own separate memory, but we can also change this as we can see later. Okay, so now we have a brief high-level understanding of how multi-agent systems work and why they're useful. Now we can actually take a step up and make this actually how this is actually used in practice. Because now, instead of thinking about agents and tools, we actually think of agents as the units in our system. Instead of focusing on how agents work, we focus on how they interact with each other. Okay, so now we can have a sequential workflow where we just have the agents in order. So we have agent 1, then we pass on to agent 2, then we pass on to agent 3. or you can have this hierarchical workflow where you have the manager agent and all these specialized agents underneath. Or we can have a network workflow where the agents are basically connected ad hoc as you wish to connect them. Okay, so let's go through this a bit slow. So once we have our basic understanding of agents, then it's all about how we put them together. So sequential workflow is basically if you want to have tasks done in a sequential order and you want to have a specialized agent for each task. If you have a phone call agent, the first agent qualifies the user, the second agent books an appointment, whatever it is, and the third agent asks for feedback. Then we have this hierarchical workflow where we have a manager agent that outsources some of the tasks to specialized agents. The specialized agents do the tasks, and then once the task is done, they send the results back to the manager agent. Then the manager agent maybe sends back the response to the user, or actually calls another specialized agent, and we do that. It's important to know that in actually complex systems, we can actually have sub agents. So this specialized agent may actually call other agents, and each of these agents at the bottom has multiple tool functions. If you remember, each agent still has multiple tool functions. So this is the hierarchy that we have. And this is why once you get to a certain point, rather than actually focusing on the low level details, we focus on the architecture and how to basically organize all of these agents and all of these tools. And then finally, we have this network approach, which I actually don't really use in practice, but can be useful. So for example, you can have just multiple agents and you let them talk to each other as they wish. In these ones, you're kind of enforcing some structure. So you can, agent one, in this case, can never speak to agent three, for example. And in this case, this agent can never speak to this one. But here we could have a way let them speak to each other, basically a free for all. This may be useful in content creation and creative purposes. So we can just let them go wild, whatever they want, maybe some game stuff. But I don't know, I've never found a practical application. There may be a lot, but I've never used this in practice, this network architecture. And there are a lot more architectures you can use. These are basically up to your imagination, but these are the main ones you usually come across in actually business use cases. Then something we need to consider as well is how the memory is shared between agents. As we saw here, there's a separate memory for each agent, but you could have a global memory. So all of the agents share the same memory. So when you pass on from one agent to the other, we actually can keep the context and keep the conversation coherent. Then a different approach is that instead of sharing all the memory, we'll make it so when an agent passes on to a separate agent, they pass on some context, but not all of the context. So for example, agent one might qualify the prospect, and then once it passes to agent two, it might send some information about the class that they've given to the prospect or the tag that they've given to the prospect to agent two. This way, agent two doesn't receive the full conversation, doesn't receive all the information about the prospect, but receives enough information. Okay, so hopefully that gives you a very quick overview of how multi-agent systems work and how and why you should use them and the advantages of using multi-agent systems because of the problems that arise when you use single agent systems. However, this is how you should tackle building agents. You should always start with a simple chat model. If you have a problem that you want to solve with AI, you start with a simple chat model. Now, let's say you start with a simple chat model, but then you come across things that can't be done with a simple chat model. If you have tool calls, calendar booking appointments, then you see, okay, simple chat model is not the model. We move on to the agents. So we should always start with an agent. So we go to the agent and we see, okay, let's add all these tools to this agent, see how this works. Then there may be a point where you have too many tools, the flow is too complex and your agent starts to perform bad. At that point, then you know, okay, multi-agent system. Okay, so now my agent was performing bad. The solution is a multi-agent system. What you shouldn't do is just, okay, I'm a cool guy, so I'm going to start with a multi-agent system, just out of nowhere. I've got two tools, I'm going to create one agent, one tool per agent, two agents, just because I want to say I have a multi-agent system. That's the wrong approach because that adds unnecessary complexity. Because as you know, a single agent can be a lot more efficient because it's the same LLM, the same model, lower costs. It can actually be faster. Memory is a lot easier to handle. So multi-agent systems do have their own disadvantages. So you should always start with a simple chat model. If you're a bit experienced, you can actually skip to the agent part when you see there's a clear tool call that you need to use. But you shouldn't go straight to multi-agent systems because you don't know if they're necessary. You might get away with a single agent system. So yeah, that's how I approach this personally, but you can obviously have your own approach. So if you're ready to implement agents into your business because you've got some ideas, maybe this video gave you some ideas on how you can outsource some of your work and create some virtual employees within your business, or maybe you don't know, but you actually want to use AI then you should book a free automation audit through the link in this description, because what I'll do there is I'll personally go through your business, analyze your business, find areas that can be automated and where real ROI can be brought to you through AI and automation. And then once we've identified the areas that can be automated, we implement these solutions using my world-class team, and we maintain them and keep them running for you, keep improving them and iterating on them so you can dominate your niche and actually bring real value to your business. So thanks for watching, and I'll see you next time.